the thing you need to understand first is where water reabsorption occurs. Okay, so this green part, it is where water, it is where tubule is permeable to water. Okay, in this red part, only electrolyte reabsorption occurs. Water is tubule is not permeable to water. Okay, and another thing to consider is in this green part, water reabsorption occurs passively, not by any channel or any pump. Okay, and what drives the passive diffusion of water? Here in this area, there is osmotic medullary gradient, which increase the osmolarity of renal medulla, and which drives the water reabsorption over here in the green part only. Okay, now what constitutes the osmotic medullary gradient? Sodium, chloride and urea. We are going to ignore urea for now, but it is one of the most important part over here. But I want to emphasize sodium and chloride is part of maintaining osmotic medullary gradient. Okay, so yeah. Now come to this. Yeah, this is showing water is reabsorbed here, and sodium and chloride is reabsorbed over here. Okay, and we all know there is a pump called sodium potassium to chloride minus in ascending loop of Henle. Okay, so keep in mind in that. Now consider we are giving mannitol to this patient. So mannitol comes over here by filtering. Mannitol filtration. Okay, just a minute. Okay, it comes over here. Now what happens is mannitol is osmotically active, so it prevents this water reabsorption, which is occurring passively. Okay, there is no pump or there is no active thing going on. It simply prevents water reabsorption. So water concentration, you can say, increase over here in this area. Now water is fine. How does sodium reabsorption decrease? That is the main question. That was the main dilemma or confusion we were having while reading Costanzo, and it was cleared by Gano. So yeah, how did this occur? Now when we are increasing the water, sodium, absolute amount of sodium remains the same. Okay, so water is increasing and sodium remains the same, so concentration of sodium goes down. Okay, here. Now what is the problem? You may ask. Yeah, okay, sodium concentration is going down. The thing is, this reabsorption part, it is occurring against the gradient, like more sodium over here and less in tubule. Okay, still sodium is going this way by consuming energy by various pump. One is NaCl co-transporter over here, another, as we mentioned before, Na2Cl minus. Okay, these are energy consuming pump which is pumping sodium out of tubule into the interstitium against the gradient by consuming energy. Okay, but the thing is, the potential to drive sodium against the concentration gradient is limited. Like we cannot have too much difference between this and this and still having sodium reabsorbed. We have very little margin of difference. Okay, that's what Gannon was trying to say. We have very little margin. When we decrease the sodium concentration in this area, this margin increase, the gradient is too high. Like sodium concentration is too little over here and too high over here. So the gradient is too high and the capacity to pump sodium against the concentration gradient of this pump, it becomes limited. So by this mechanism, sodium reabsorption decreases. That is the bottom line in both the book mentioned. Okay, so sodium reabsorption decreased. And as we know, water reabsorption also decreased. So in overall effect is sodium and water remains more in the tubule, and it goes out in urine. Okay, that is the initial thing. Another thing to consider is another thing to consider is when we decrease the sodium reabsorption in this area, the as we first mentioned, oncotic medullary gradient, osmotic medullary gradient is maintained by sodium, chloride, and urea. Now we are not absorbing sodium and chloride much, so this gradient goes down. This and by sorry, and this gradient goes down. So less, and this gradient is what driving the water reabsorption. So the amplifying effect would be we are reabsorbing less water, then we are reabsorbing less sodium, so we are having less sodium for osmotic medullary gradient, then again we are absorbing lesser water, you can say. So the thing is the tubular fluid become not more diluted but increase in content of sodium and water both. It is increasing isoosmotically. So concentration sorry, discard the last part, but yeah, we are reabsorbing less and less of water, and along with that we are reabsorbing less and less of sodium, and uh, more tubular fluid containing sodium and water goes out. This is same for glucose. The thing is glucose is naturally occurring, and the point is the body tries to maximally absorb glucose over in PCT, proximal convoluted tubule. So when it reaches its maximum capacity, because this is reabsorbed by sodium glucose co-transporter, which we can call as GLT. There are subtypes to it, but it doesn't matter over here. So when this pump reaches its transport maximum, no more glucose is reabsorbed, so glucose remains in the tubule. It reaches the loop of Henle and have the same effect as the mannitol. And overall, this amplifying effect cause osmotic diuresis. In Ganong, it is also mentioned that you can produce so much fluid by doing osmotic diuresis. So it is very potent thing. So yeah, I hope it is very clear. And this is my first time recording a video, and I'm not an English speaker, native English speaker. So I'm consider this is trying my best. Okay, thanks. Bye bye.